Hello and welcome to this video on imposter creation in Unity using remeshing. We are going to optimize this asset, or rather collection of assets. This house is made up of a lot of different models. It has an inside and it has a total of 16 different materials. If we would want to optimize this model for distant viewing, then we would want a very cheap model to render. And if we can look at the wireframe, we can see that this is not a very cheap model to render. We also have overdraw, because we have inside in the house, and also we have 16 different draw calls. So we are going to start by doing the most naive thing we can think of. We are going to use reduction to optimize this model. We go to the Simplygon menu, add load component, template, basic, reduction. Then we are going to try to optimize this down to 5000 triangles. So we can now look at the result, and it does not look good at all. In fact, even if we would zoom out a bit from it, it looks quite broken. Also, we have not addressed any of the internal phases, nor the amount of draw calls it takes to render this model. So we're gonna move this mistake quite far away. Instead, now we're gonna try to do a remeshing of this asset. So we go to the Simplygon menu, click Add Load Component, Template, Basic, and Remeshing with Material Baking. You can think of a remeshing like we put shrink wrap around the model. If we expand remeshing settings here, we can see that we have a hole filling setting. And that hole filling setting determines how likely the shrink wrap is to be sucked into these holes in our windows, for example. The overall quality metric we use is screen size. So let's leave that at 300 pixels. We can specify the output material size here in mapping image setting, output material settings, and we're going to increase it to a 4K texture. We can see that we already got some material clusters set up, so it automatically detects which channel that is in our materials. And all of the materials that we use for this asset are HDRP lit ones. And these ones have a base map, a mask map, and a normal map. It is important to notice that we only support certain materials for material casting. Please consult the documentation which one we support out of the box. But here you can see that we have the base map, the normal map, and the mask map casters for those channels. Now let's try to do a remeshing. So here is our resulting model, and as you can see, it looks much more nice. In fact, even from this distance, it is a little bit hard to figure out which model is which model. But if we look at the wireframe, then it's suddenly a lot easier to figure that out. The model uses only one material, and we can see that all of our channels, so our base, mask, and normal map, have been baked to textures. Any small geometry details, for example the windows, are also present in this normal map, but it also takes any existing normal map into account. If we look on the inside of it, we can see that it is empty, or almost complete empty. If we zoom down here, we can see that on the foot of our model, it is not hollow. And in fact, it's kind of a mystery, because in the original model, it was hollow. So what has happened? What has happened is that remeshing always create a watertight mesh. And for this part, it is not watertight. So what has happened is that we've created a watertight model of it. So this one is double-sided. And we don't want that. It wastes a little bit of texture space, and we have a little bit overdraw and a few more vertices. But this could be a much bigger issue if the entire house would be double-sided, for example. That would be the case if we, for example, would optimize a skyscraper. So, in order to remove the double-sidedness, we need to plug up this hole. And we are going to do that by clipping geometry. We select our ground plane, and then we add a Simplygon selection set. And we name this ground. Then we're going to switch into an advanced remeshing pipeline. So we go to Add Load Component, Template, Advanced Remeshing. Here we can now find a lot of more settings, but we're just going to keep them as is. We're going to specify that we want to use clipping geometry and specify that it's the ground selection set that we just created. We're also going to go into mapping image settings and specify that we want a 4K output texture. We still have our same material casters for our material channels. Now let's try this again. And here is the result. If we zoom in and look on the underside, we can see that it is now empty, as we expect. And it also looks really good. We don't really see a difference in texture, but we have a little bit of better UV usage in this one. And wireframe still looks really simple. Now, it is pretty impressive that we've gone from this, that is over 200,000 triangles, down to this one, which is below 3,000 triangles. And especially if we compare these two to our trial with reduction, we can see that it outcompetes the reduction in any way possible. So if you want to create proxy meshes that you want to showcase far away, remeshing is the way to go. So that's all for today. I hope that you have learned something. If you want to know more about how you can use Simplygon to optimize Unity games, please follow our channel. Thank you.